everybody, Bryce here with WhipMix Corporation. Today we're going to be doing a webinar with the new Splint Studio. Splint Studio is a new piece of software from 3Shape. It's only been out, I think, a few months at this point, um, and we're really excited about it. It's a really great piece of software that is a big improvement on the previous software. So we're going to be talking about a lot of different pieces of equipment today, materials, processes, the whole nine yards. So let's go ahead and let's dive in. So the first thing that you might be asking is why splints to begin with? You might have a good routine at your lab. Maybe you're a fixed lab and you're not sure you really want to dive into something like that, or maybe you're doing splints analog and you don't see much of a reason to switch to digital. We're going to talk about all of that today. The biggest reason that I really like doing digital splints is the quick design. So you're going to see as we go through the new Splint Studio, it is very quick and efficient to design these splints. It's much faster than the old splint design software, and as we all know, time is money, and the less time you have to spend on a restoration or a prosthesis or appliance, the more profit really you're making. So quick design is number one. The second reason is the ease of manufacturing. So these splints are actually very easy to manufacture. So today we're going to be talking about manufacturing these via 3D printing. 3D printing, in my opinion, is the best way to manufacture these splints. It's the fastest and it's the most cost efficient. And with cost efficiency, we're going to talk about the third reason why I like digital splints, increased profitability. Basically, it's a simple equation. If you spend less time manufacturing something and you spend less on the materials, your profit margin goes up. It's as easy as that. So this is going to be true for labs or doctors. If doctors are going to do this in-house, the same principles apply to you. So that's really the third biggest reason why I like digital splints. Finally, the last reason is to simply increase your lab or your practice's offerings. Everybody really likes the being able to get everything from one source. That's why retailers like Walmart and Amazon have just exploded. Is because if you can walk into a store and get everything that you need from that one place, there's a big marketing advantage to that. So by offering splints, if you're not already offering them, it's one more thing to add to your lab's offering to entice new doctors to try you out. So we're going to be talking about some different pieces of equipment that you're going to need in-house to manufacture these yourself. As you can see on the screen, we've got the Asiga 3D printer. This one is the Asiga Max. This is kind of the flagship for Asiga. And we also have our very own WhipMix VeriSplint OS resin. So this resin is 510K cleared in the United States for intraoral use as a Class 2 medical device. You do need to print it in the Asiga Max, and you need to cure it in either the Auto Flash or the Uvatron curing units to maintain that 510K clearance. Let's talk a little bit about the workflow. Just like anything else, your basic workflow is going to be scan, design, and print. When it comes to scanning, you have different options. You can, if you have a desktop scanner like the E-Series scanner, for example, you can receive just regular either alginate or polyvinyl impressions from the doctor, and you can pour those up. Then you can scan in those casts. The other option is to scan in an impression, and then the third option is intraoral scan. So if you are a doctor and you have an intraoral scanner, you can send those files and import those into 3Shape, and then you can use those digital impressions, which is a fantastic option. Design is kind of self-explanatory. We obviously have to design the actual splint. Today, again, we're going to be talking about the new Splint Studio from 3Shape. And then finally, print. when I say print, really what I mean is just manufacture. You can mill these, that is entirely possible. However, it does take much longer, and it's going to cost more in materials to mill these splints. Um, so we're going to be talking about printing today. So let's talk a little bit about what you need in terms of 3Shape software. So if you have Dental System Complete Restorative or Dental System Premium, you already have access to Splint Studio because both of those packages include the Splint Designer by default. So if you have one of those, you're good. Now let's say you've got like Dental System Crown and Bridge or Dental System Removables. You can add on just Splint Designer as an add-on module to your subscription. This is a good option if you just want to add on splints and nothing else, and it's going to save you a little bit of cash rather than just upgrading all the way to complete restorative. Okay, so again, when it comes to scanning, you can either scan intraorally with the lovely Trios scanner, or you can scan in on your 3Shape desktop scanner, such as the E3 or the E4 scanner. And again, we're going to be designing today in Splint Studio. Now, I do want to point out that Splint Studio is actually built into Dental Desktop. So those of you that are using Implant Studio, for example, you're already going to be a little bit familiar with Dental Desktop. For those of you that aren't, Dental Desktop is a separate piece of software from 3Shape that is set apart from the regular dental system. There are reasons why they added Splint Studio into Dental Desktop that we're not going to get into today. Okay, so let's talk a little bit about printing. I already touched on this a few minutes ago, but when it comes to printing a splint, and this is also true of printing things like dentures, so anything that's going to be long-term intraoral use. These medical devices are classified by the FDA as a Class 2 medical device, meaning it is indicated for long-term intraoral use. Any 3D printed bite splint needs to have a 510K clearance, which is that classification from the FDA. And when we talk about this 510K, we're talking about it in the context of an entire ecosystem. The ecosystem that we're going to be talking about today is going to be the Asiga Max printer with the VeriSplint OS resin from Whitmix and the auto flash curing unit. What I do want to point out is that this is the 510K that we have here at Whitmix. Now, let's say there's a lot of interest in the Keystone resin, for example. What you can't necessarily do is just swap out one of these components. So, for example, let's say you've got an Asiga Max and you've got the VeriSplint OS resin, but you don't have the auto flash. You have the curing unit from, I don't know, B9 Creations or GC. What you can't do is just swap out those curing units. If you use a different curing unit to cure a VeriSplint appliance that was printed on the Asiga Max, that is not 510K because it is not part of that entire ecosystem. So it's a little confusing. If you have any further questions, feel free to reach out to us at Whitmix, and we're more than happy to go over that with you. Okay, so what I'd like to do at this point is start to actually go over the software. So one nice thing about Splint Studio is that you can link it to your regular dental manager so that you can access everything from one software. So to do that, what we're actually going to do is we're going to go into our dental system control panel. And then if we go into system settings, we can see all of our installation file paths. And right here under Splint Studio, we have the installation file path for Dental Desktop. If you need help linking this, that's no problem at all. Just give us a call and we're more than happy to help with that. So by linking Splint Studio to our dental system, what we can actually do is create our order here in our dental manager. So we're going to start by creating a new order here in the upper left-hand corner of the screen. And it's going to generate our new order screen. So let's just call this Splint webinar. And today we're going to be making a maxillary splint. So I'm just going to click any tooth on the maxillary arch, doesn't matter which one. And then I'm going to click down here where it says appliance. Now it's going to default the first option to a splint, so that's perfect. The only other thing that I'm going to do right now is I'm going to change our object type from model to digital impression because I'm going to be importing our scans. And then I'm going to click OK. So now I can see that it has generated our new order. To import our scans, I'm going to right click on that order and then click import scan. Let's see. So first it's asking us for our upper jaw. So I'm going to click maxillary, and then it's going to prompt me for the antagonist, mandibular. To start designing, I'm going to right click on the case, and then I'm going to click the Splint Studio button right here. Now, Splint Studio may take a minute or two to open because it does have to open up the dental desktop. So if it takes a minute, just be patient. It will open eventually. Okay, so here we have our Splint Studio. So just like in all of your other 3Shape software, up here at the top of the screen, we have all of the major steps that have to be completed before we can finish and export the STL file. And then over here on the left-hand side is kind of more information about the current step that we're on. So the nice thing about Splint Studio is up here at the top, it's going to tell you exactly what to do next. So the first thing we need to do is we need to select a machine or material. So I'm going to select Formlabs. We are currently working with 3Shape on getting the Asiga Max added to this list, but for right now, we're just going to choose Formlabs. So now what we need to do, as the software is prompting us, we need to click the mesiolingual cusp tip on tooth number 16. Now I haven't changed the tooth notation from FDI to universal, so that's why tooth 16 is over here. Click where the mesial and incisal edges meet on the incisors. So I'm going to click right here, kind of on the midline. And then finally, click the mesiolingual cusp tip on tooth 26. So I'm going to click right back here. And now the software is going to automatically generate that occlusal plane for us, which is really, really nice. From here, I'm just going to click next. So now I can see we are in the bite configuration phase. So what we're actually doing here is we're opening the bite virtually to accommodate a certain posterior splint thickness. So with our Whitmix VeriSplint OS resin, we recommend a minimum thickness of 2 millimeters. So to change or to make sure that that's set properly, right here where it says open to splint thickness, I'm just going to make sure this value is set to 2 millimeters. Now, different resins might have different requirements, so you definitely want to check with the manufacturer of the resin to make sure you're setting this properly. So what I need to do now, I'm going to click this like kind of double black arrow icon right here. That's going to actually go ahead and open the bite for me. And then I need to click the lock button right here to lock that in place. Once I've done that, I'm going to click next. So now we are in the insertion direction and blocking out phase. So the software is going to automatically generate a perfectly vertical path of insertion and blocking out direction, but we can change that if need be. The best way to change the block out direction is to find an occlusal view that we want to use as our path of insertion, and then click the From View button right here on the left-hand side of the screen. Once I click that, I can see down here in the bottom left-hand corner, it's going to recalculate our blockout wax. Okay, so now we have our new blockout wax generation based on our new path of insertion. Over here on the left-hand side of the screen, we do have some customization options. The first one is perform undercuts removal. If we don't want to block anything out, I can actually turn that off and remove all blockout wax entirely. Probably don't recommend that though. The other thing we can do, we can change the blockout angle. So right now it's set to 0. So the angle of blockout is perfectly parallel with our path of insertion. However, if I bump this up to, let's say, 6 degrees, watch down here, you're going to see our blockout wax change dramatically. So now we can see that that blockout wax has flared out by 6 degrees. For today, we're just going to leave that at 0. We also have retention amount. So what retention amount is going to do, in this case I have it set to 50 microns. So we can see here these blue areas that we see, these are areas that have less than 50 microns of undercut, and the software has removed blockout wax from those areas. So retention amount lets you set a custom amount of retention based on the depth of undercut. So if I set this to 0.1, any undercuts that are 0.1 millimeters or less will not be blocked out. So this is a number that you're probably going to want to play with a little bit. You're probably not going to get it spot on your first try, and it's going to require a little bit of experimentation. Once we set that retention amount where we want, I'm going to click Next. So now we're in the wax trimming phase. So now we can actually sculpt on our blockout wax. If we want to add any blockout wax, we can use our wax knife to do so. If we want to remove, we can remove. And if we want to smooth, we can smooth blockout wax. So this wax knife is exactly the same as the wax knife that is prevalent throughout all 3Shape software. I'm going to click Next. So now we are in the draw outline phase. So at this point, we're actually going to draw the outline of our splint. You can start anywhere. Doesn't matter where you start. I'll just start back here on this molar. And you can either click and drag to draw your outline, or you can do single clicks to design it. To complete the spline line, I'm just going to drag it back to the original point to finish the loop. At this point, I can come back and I can make any corrections that I'd like to make. Once I'm finished drawing my line, I can click Next. However, I want to go over some of the settings over here on the left-hand side of the screen. So first we have splint thickness. So this is going to be the minimum thickness required by the manufacturer that you chose in the beginning. In this case, we're going to leave this at 2 millimeters. The minimum thickness is going to be required to be between the minimum thickness and maximum material thickness. So I'm going to set this to 2 as well. Offset from teeth to splint. So this is basically your cement gap. So whatever value you enter here is going to create space in between the teeth and the intaglio of the splint. So it's just basically like a custom relief. I'm going to leave this, or I'm going to set this to 0.05, so 50 microns of offset. And then drill diameter is going to be a drill radius necessary for milling the splint. So if you're milling, you need to set the drill diameter to the size of the smallest tool that's going to be milling the inside of the splint. Since we're printing, I'm just going to leave this at 0. So now we're going to actually set up the design and function of our splint. So we have 3 options here for function. We have raise to antagonist cusp tips, we have raise to antagonist plane, and we have raise ramp. What I'm going to do today, I'm going to use raise to antagonist cusp tips for our posterior teeth. And then I'm going to use a raise ramp for our canine and anterior guidance. I can change the ramp angle if I want. I can turn it up. Let's bump it up to 25 degrees. Once I've set up the design, I'm going to click Next. And now we just simply need to wait for the software to generate our splint design. Okay, so here's our initial proposal. This is typically going to be pretty darn close to what your final design is going to be. From here, we can do a few things. Right here, I can see we have a notification that the design is 0.5 millimeters thinner than the recommended 2 millimeter material thickness. Do we want to correct that or accept it? I'm just going to go ahead and click correct. Now it's going to calculate and fix those areas. And now I'm ready to move on. So from here, some other things that we can do. Down here at the bottom of the screen, we have an adapt design option. What this is going to do, the software is going to, if I click this play button right here, the software is going to analyze all of the excursive movements, and it's going to adapt our splint exactly to those movements. So we're going to see that the software is going to reduce areas where we're making contact in dynamic occlusion. Now I'm going to undo that because I want to show you another cool feature of the software. So over here, kind of down in that same general area, we have a button that says enables/disables the area selection mode. So what I can do, I can highlight areas that I want to lock and not modify. So if I highlight, let's highlight canine to canine, and then I press the adapt design button again, it's only going to adapt the posterior teeth. It's going to lock and preserve that ramp that we created on the anteriors. So that's kind of a really nice option. I can see this heat map that's showing up on our appliance. This is a distance map. So this is showing us how far either in occlusion or out of occlusion our splint is with the antagonist. So over here we have a scale that's showing us those distances. So the red down into the blue colors, those are going to be positive contact with the antagonist. Now, as we work our way up from the red color up through oranges, yellows, and greens, those areas are out of occlusion. So this is a really nice tool to help you kind of see and gauge where exactly your occlusion is on your splint. We also have a wax knife option here. So again, I can add, remove, or smooth. So I can use this add tool to kind of come in and smooth some areas out if I don't want there to be so much contour there. I can use the smooth tool to kind of blend those areas together a little bit. Now we also have a morphing tool right here. So if I click the morphing tool, those of you that have been using 3Shape are going to be already familiar with this, but what this allows me to do is actually pick up and like I'm using tweezers and actually grab data. So I can pick it up and manipulate that data however I want. So it can be a very useful tool. So I can use this to kind of smooth out some of the contouring in certain areas. Then I can come back with my smoothing tool and smooth those out. Very useful. I do need to select an option on the notification. I'm just going to click accept. So once we're finished with our design, I just need to wait for the next button to not be grayed out anymore. And once that happens, I'm just going to click next. And now the software is going to save and close our design. From here, what we can do, we can actually right click on this case now. I can go to advanced and generate cam output. That's actually going to go ahead and export the STL file for us to 3D print. Now if I right click again, go to advanced and then explore cam, that's going to open that manufacturing directory. So now if I double click on this STL file, it's going to open up in 3Shape 3D Viewer our splint. And this is ready to print. So now what I'd like to go over briefly is the Asiga Composer software. We're not going to get super in depth with this because it's very much product specific, but I do want to demonstrate how easy it is to nest these splints in Asiga Composer. So I've already opened the software. I'm going to click New to start a new print job. Now, typically on this new build screen, you're going to do three things. You're going to select your printer, you're going to select your material, and you're going to select your slice thickness. Now, since I'm working from home, I don't actually have a printer here to select, so I'm just going to select a virtual machine. And then again, I don't have our VeriSplint OS resin in here loaded, so I'm just going to select. We'll just go with Plas Clear. And then for slice thickness, I'm going to leave this at 50 microns. That's usually where I print my splints. I'm going to click OK. And now we have our new build screen. So this gray and black grid that you can see here, this is our virtual build plate. In the bounding box around it is our print area. So let's go ahead and add our STL file. I'm going to click the Add Parts button, select Files, and then I'm going to select our splint, click Open, and then Open. And it's going to load that STL file. So I can see that it's not in optimal position. It's not even in our print area. So we need to change that. So I'm going to start manipulating and moving this splint around to get it properly nested. So now I need to rotate it 180 degrees. When I print these, I print with the occlusal side down, so the supports are on the occlusal side. They're much easier to remove and smooth out on the occlusal rather than the intaglio. So I'm going to rotate this. So I'm going to use the rotate tool down here in the bottom left-hand side of the screen. I'm going to rotate it around the y-axis. And now we've rotated that splint perfectly 180 degrees. You can angle these a little bit if you want, or you can print them perfectly horizontal. I just don't recommend printing them vertically. We have found that printing these vertically results in a much tighter fitting splint than what you designed. So I recommend either flat or slightly angled. So now we need to add some supports. To add supports, I'm going to go to the Add Supports button on our toolbar. And then I'm simply going to click the Apply button. The software is going to automatically generate supports in the necessary areas. Once they have been generated, I'm going to click Close. And this is ready to send to the printer. So to actually send it, I'm going to click this green play button. This is the build wizard. This first screen, I'm just going to click Next. The second screen allows me to add a base plate. So anytime I print an object on supports, I print a base plate underneath. The reason being is the more surface area you're printing directly onto the build plate, the better adhesion you're going to get. So these support structures on their own don't really have a whole lot of surface area. So I'm going to create a base plate underneath of them to create better adhesion to our build plate. Typically, I'm going to print this base plate in a 400 micron layer, and I'm going to print it as a shadow. So what shadow is going to do is it's going to basically just create an exact shadow underneath of that object, and it's going to print a base plate in the shape of that object underneath. I'm going to turn on fast print mode, and then I'm going to click Next. Here we have advanced parameters. I'm not going to change any of these, and quite frankly, neither should you. All of this information comes over in the INI file that you loaded, or that we loaded for you. Click Next. And then the final step is to name the build and then click Send. Once you click Send, the software is going to basically chop everything up into slices. It's going to compile those slices into a single file, and it's going to send that file over to your printer. And that's pretty much it. Splints with the new Splint Studio are very easy, very quick, very profitable, and very intuitive. I definitely recommend, if you're not currently offering splints in your lab or practice, to start offering them. The learning curve is not very steep for these. If you are already doing splints and you have yet to transition them digital, I recommend looking into that as well, because I think you'll find that your profit margin is going to go much higher. And quite frankly, I think you're going to be able to offer a better product to your patients. If you have Splint Designer on your 3-shape dongle and you need help installing Splint Studio, just give us a call or shoot us an email, and we're more than happy to help with that. Our phone number is 1-800-626-5651, extension 1437, and our email address is productsupport@whitmix.com. Thanks for tuning in. We'll talk to you soon.